In this video, we will solve a question on matrix multiplication. The question is, given two matrices, that is, we are being given matrix A and matrix B. We need to find out the product of matrix A and B, that is AB. Okay, so all the matrices are not, conformable for multiplication. The condition is we can multiply two matrices only when the number of columns in the first matrix are equal to the number of rows in the second matrix. Okay, now let us see here what is the order of this matrix. Order shows us number of rows and columns. Okay, so number of rows in the first matrix is, let us see, 1 1 and 2. So we have 2 into, and number of columns is 1 2 3. Okay, this is the order of the first matrix, and let us see what the order of second matrix. So number of rows is 1 2 3, and number of columns is 1 and 2. Okay, this is the order. I am writing it here. So two matrices can be multiplied only when the number of rows in the first matrix are equal to the number of columns in the second matrix. Here you can see number of rows in the first matrix are 2 and number of columns in the second matrix is 2. So we can say we can multiply these two matrices. And what will be the order of new matrix? So order of new matrix will be equal to 2 into 3. Let us write it in this fashion. And here we have 3 into 2. Okay, so the order will be equal to, okay, so order will be left with 2 into 2. So the new matrix format, its order will be 2 into 2. That means there will be 2 rows and 2 columns in the next new matrix. Here conformability is applicable because the number of rows in the first column are exactly equal to the number of columns in the second matrix. So let me write it here. AB, that means product of these two matrices will be equal to. So how do we multiply? We multiply corresponding row with column. So corresponding row with corresponding column here. So we multiply first row with first column here. So we have 1 into 1 1 into, and let me write it here, 1 plus, then we have 2 into 3 2 into 3 plus, then we have 3 into 0. So we have 3 into 0. Okay, so we multiply first row with first column, then we multiply first row again with second column. Okay, so we have again 1 into 2 here. So we have 1, let us use the proper color here. So we have 1 into 2. So we are multiplying this row and this column this time, plus, then we have 2 into 4 2 into 4, then we have 3 into 6 3 into 6. Okay, after that we multiply second row with these two columns. So second row is 4 into 1. So this 4 into 1, we have 4 into 1, plus, then we have 5 into 3 5 into 3, plus 6 into 0 6 into 0. Okay, after that again we multiply this row with this column. So again we have 4 into, this time we have 2, plus 5 into this 5 and this 4, plus 6 into 6. Okay, let's write it here, 6 into 6. Now when we multiply it, so our AB will be equal to, so 1 1s are 1, 2 3s are 6. Okay, 1 plus 6, then 4 ones are 4 plus 5 threes are 15, 6 zeros are 0 again. So here 1 twos are 2 plus 2 fours are 8 plus 3 sixes are 18. Here we have 4 twos are 8 plus 5 fours are 20, 6 sixes are 36. So this reduces to, we get, so 6 plus 1 is 7, 15 plus 4 is 19, you got 28, 28. So this comes out to be shivanza, so it comes out to be 64. So the product of these two matrices comes out to be 7, 19, 28 and 64. Okay, so it is very simple. Let me repeat it here. If we want to multiply two matrices with different orders, okay, and then the condition for their multiplication, that means two matrices are conformable for multiplication only if the number of rows in the first matrix are equal to the number of columns in the second matrix. Number of rows in the first matrices are 2 and number of columns in the second matrix are 2, so we can say we can multiply them. Okay, then we multiply each row with its corresponding column. Thank you.